Hello, we're back again. This is Learning Guide 4, Logarithmic Functions. This is part 2 now of the seminar. And we are going to look at some graphs today. So first of all, we are going to look at the change of base rule for logarithmics. Because there are going to be times when you need to use your calculator to do some evaluation of logs. And so we call this the change of base. I call it the COB rule, change of base rule. Okay, so it's going to be using our calculator now. Okay, so first of all, let's just get our calculators out and find mine here. There it is. Now, the example I have for us to practice is this one here, log base 3 to the argument of 243. So we're going to get out of the graphing mode here, and this is clear. So what we're going to do is go log of the argument. So remember, this guy right here is the argument. We'll call A. Okay, so we're going to go log of the argument. So 243, close the bracket, divided by log of the base. So this guy right here is the base. Okay, so we're going to go log 3. And then we hit enter, and our answer is 5. Okay, so that's how we do that. So just to recap it, remember the change of base rule is log of A, the argument, divides by log of B. Okay, so that's the quick and easy way. All right, so let's move on. So now we're going to deal with some graphs now. So this is just recapping on stuff we did earlier in Learning Guide 3, exponential functions. All right, so let's just look at the exponential function, y equals 2x. So let's just input these numbers right here into the x to get some y values. So 2 to the negative 3 is 1/8. 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. And 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. And 2 cubed is 8. Okay? So now, remembering back to Learning Guide 3, there's an asymptote. Remember we had asymptotes, y equaled some number. And remember that the number out here is our asymptote. Well, because we have no number out there, it is 0. So we have a line, I'll just make a line here. We have a line, y equals 0. So I'm just going to go here and pick yellow as my line and make a line y equals yellow. Okay, so there is our asymptote right there. All right. Now, if we want to plot these points right here, we can just plot them. So let's use green now. So if we go over negative 3 and we go up 1/8, we go over 2, negative 2, we go up 1/4, then we go up 1/2, then we go up to 1, and then we go 1 is 2, and 2 is 4, and it's up to 8. So that's something we did. So it sort of looks like that, right? Okay, so there is our exponential function. Now, you're going to see a relationship now between the two. So now we are going to do a table of values here for this log function. But before we can do the table of values, we have to write it in this exponential form. So we can do some easy math to get it in. So we just do the boot up that y, so 2 to the y equals x. Now you notice that y is now the exponent. So now I put all these numbers here, not like I did over here, made up random numbers. I'm making up these random numbers to put into the y so I can get that x. So we know we get 1/8. Put 2 in there, I get 1/4. Get 1/2. Get 1. So you're probably seeing there is a pattern going on here. And if you said to yourself, it's just inversing. You're changing the x's with the y's with the x's. You are right, because that's the relationship between this exponential function and this log function. They just switch. Now watch when we see the graph. Now, before I draw the graph, I want to figure out this asymptote. Now this asymptote comes from whatever's inside the bracket with the argument. So we have to look at this argument. I'll put a bracket because sometimes they don't. Now there's nothing there. So I know my asymptote, not y, we're doing the inverse, is x equals 0. Okay, see how this is y equals 0, x equals 0. Okay, so let's put a line in. So let's just go and put in a red line at x equals 0. So we know it's going to go right through there. Okay, now we're going to put some points on. Okay, so let's go over 1/8, down 3. Let's go over, down 2, and then there, and then over 1, 0, over 2, 1, over 4, 2, over 8, 3, and now we have the sketch that looks like that. So you can see that they are an inverse of each other. If we fold it on this line, the inverse line, which is y equals x, okay, so if you fold it on this line here, okay, I'll try and draw y equals x there, and then, okay, you can see that it's an inverse of each other. All right, so let's move on. Okay, now we have some transformations. Okay, the stuff I just taught you, the slide before, a few seconds ago, is a really good lead-in to this topic, the transformation. Now, we're going to use our skills that we learned in 1 and 2, these transformation tools, and we're going to get some clear picture for how to draw. So the first thing I want you to do is tell me the asymptote. So the asymptote comes from the bracket. Okay, so it's the opposite of -3, or we get +3. Okay, so that's the first thing you have to pick off, is that the asymptote comes from the bracket. So now I'm going to go and draw a line, and we are going to put a line at x equals 3. So a nice line, oops, sorry. Let's just straighten that line out, not a very good line. Right there is our line. And now, we are going to now make another line. This is not an asymptote. This is just going to be our shifting, our translation of the function now. It's going to go up 1. So this line I'm drawing is just helps you with the translation. Okay, so let's just make this a different color. Let's make it green. So this line right here, I'm making it nice and light. Maybe that's too light. Make it a little bit darker. So let's make it heavier. Okay, so now what I've just done now is drawn in my asymptote, and remember on the test you always have to label asymptotes. You lose a half a mark if you don't. Just tell me that x equals 3. Okay, it's very important. Now what I've just done is stripped this away and this away by making these two lines. So what I'm left with is the basic function of y equals log 2 to x. Okay, that's all I've done. Now remember we use the base function and find some points. So I've memorized these points, that it's 1 and 0, 2 and 1, and 4 and 2. Those are the base points from that function right there. Now how did I do that? Well, I'll show you. It's just the boot up rule we did earlier. This 2 boots that up, so we have 2 to the y equals x. Okay. Now remember, I am going to use these for my input, the y values. So what I've just basically done is I took 0, I put it in there, I got my 1, I put 1 in there, I got a 2, I put a 2 in there, and I got a 4. That's all I did. Nothing magical there. It's pretty straightforward. Okay, now let's graph. So we go, oh, remember this is our origin now. We're not here, we're right here because of our transformation. Okay, so I go 1 over 0, put a dot, 2 over 1 up, 4 over 2 up, and remember this is an asymptote right here, so we know it's hugging it, and it comes right through those points and then sort of scoops away. So there is a sketch. Now once you have a sketch, you know that the domain comes from this asymptote. So we say x, numbers greater than 3, and the range is all real.